this is the very important part. Condition for maximum efficiency. Okay. So just wait. Okay, this problem. Condition for maximum efficiency. Okay, we are ready. All students, please using the notebook, okay, and noted this, okay. This topics condition for maximum efficiency. You know that our efficiency means this the eta is equal to this called eta, okay. This called, repeat, this called eta. This is the efficiency, and efficiency format is the output by input. Okay, all are clear? Efficiency means output by input, and percentage of efficiency is into 100. Okay, all are clear?
Yes, sir.
No, sir. Repeat again, please.
These topics already finished. This is the efficiency. This is the eta, mechanical efficiency. This is the output, mechanical output by mechanical input. Okay. This is the electrical efficiency, electrical output by electrical input, and commercial efficiency. This is the overall efficiency. This is the last and first. Okay. This is the C by A. This is the output and this is the input. This is called overall or commercial efficiency. Okay. And already one problem solved our previous class. So this problem already solved this. This is the percentage of efficiency. Okay, mechanical efficiency 98.2%, and this is the 95.9% and 94.2%. This is the efficiency. Okay, all are clear?
Yes, sir.
So this this day just some repeat these topics. This is the efficiency means output by input, and also percentage of efficiency is equal to output by input into 100. Okay, so to know that our generator output means this the last stage. Our generation output last stage, power stage, power stage. This is the last stage. This part our last stage. Okay, so this is the generation output VI. All are clear? So this is the generation output, and this is the generation input. Okay, mechanical power input or output of driving engine. You know that this value BHP, brake horsepower, into 746.46. Okay, this is the mechanical power input. So this is the total generation input, this, and this is the total generation output. Okay, suppose your development 1000 watt, but your final output 800. So this system is loss.
Yes, there may be losses, sir.
200 loss. Okay. Yeah. So this is the fact.
Sir.
So,
may you write, sir, the loss formula, sir?
Sorry.
Sir, in electric power developed, is it input or output?
Electric power developed. This is the input of this part, but
Yes.
final main input this is the
Starting
input,
point,
and
sir.
now this part to this part, then this is the input, this is the output, and this is the mechanical and magnetic part, and this is the electrical part. Electrical part, this is the input and this is the output. Overall, full generation, main input this and main output this. Okay, all are clear?
Yes, sir.
Okay.
Sir, may you write the formula, the loss formula, sir?
Loss formula.
Yes, sir. For example, sir, CO losses, iron and friction losses, sir.
Iron and friction loss, this is the
Yes,
this
this.
is the fixed. Iron and friction loss, if you calculate this value, then and you know that suppose this result, then this result minus this part, then this is the iron and friction loss. Okay, and suppose your result, you know that this value, suppose 1000, and this value suppose 800. So copper loss
Yes.
means copper loss 200. 8,000 and 800. Okay, this is the input and this is the output. So this 200 is loss. Okay, this is a very simple loss calculation. Okay, now we check. So this is the condition for maximum efficiency. You know that generation output is equal to VI. Okay, generator output is equal to VI, and you know that input is equal to output. This, sorry.
Blast losses, sir. Losses like CO and friction and iron loss.
Yes, good. So this your power stage, suppose. Okay, this is your power stage. This is your output, VI. Okay, and this is the input. Okay, this is the input and this is the output. Okay, so this is the input, this is the VI. Sorry, output, this is the VI. So input is equal to
Output plus losses.
is equal to
Output plus losses. Blast losses.
plus loss.
Losses.
This is a very
Yes.
simple.
Yes.
Or output is equal to input minus loss. Input minus loss, then this is the output. Okay, suppose input 200, input is the 1000 and loss 200. So 1000 minus 200, this is the output 800. Okay, so this a very simple equation. Input is equal to output plus loss. So this is the input is equal to output plus loss. Okay, input is equal to output plus loss. Clear? All clear? This
So,
line?
sir, when it should be, no, sir. Listen,
Sorry.
listen, sir. When it should be, when you are finding the output, when it should be input minus loss. When?
I don't understand your point. Repeat.
I said when you are finding or when you are finding the value of output. Hello.
Yes. Find the value of output. Okay.
Yeah,
Okay.
sir. So when it should be, input minus loss.
Yes. Then input.
The condition. I need the condition, sir.
Suppose you understand loss value and you understand the input value. So output is equal to input minus loss. Okay, and suppose you understand the calculation result, then you are calculate the total loss. Suppose calculate the formula using formula, then you find out the total loss. Then you know that total loss is equal to this and if the another calculation, this the output is equal to this, is then input is equal to what is this? So in output plus loss is equal to input. Next math solution, then clear this. Okay, at first condition.
Okay, sir.
This part
Okay.
condition complete this. Okay, so now you know that
Okay, sir.
input is equal to output plus loss. Okay, so you know that output is equal to vi, output is equal to this the output is equal to vi. Okay, or load voltage and load current same. Okay, so this plus loss is equal to, you know that loss two types. Loss is equal to variable loss plus constant loss. Main two part loss, variable loss plus constant loss. Okay, and you know that variable loss, only armature loss is the variable loss, Ia square Ra, this is the variable loss. And you know that this is the constant loss, WC. Constant loss means total loss, all loss. Okay, you are clear this point? This already this session is complete, our previous class. This is the this all loss, this iron loss and mechanical loss, this called steel loss, and this iron loss, mechanical loss, and these two loss, this called constant loss. And only armature, this part, only armature is the variable loss. Okay, all are clear?
Yes, sir.
So
Sir.
loss is equal to
Yes, sir.
this is the variable loss and this is the constant loss. So this is the total loss. Okay, so we use this Ia square Ra plus WC, call this. Okay, clear? And
Yes, sir.
you know that Ia, this your just generation. Okay, then this is the divide. So this is the Ia. Ia is equal to all time. Ia is equal to ISS, and this is the I. Okay, all time. If this is shunt, if series, then only Ia this is the one. But if shunt, then this Ia is equal to then Vi plus Ia is equal to, you know that Ia is equal to ISS plus IL or I. Okay, this, so just change this one. Okay, Ia is equal to ISS plus I whole square Ra plus WC. Okay, all are clear?
Sir.
Now, this is the very important fact. This is the ISS. You know that our current flow, maximum current flow, this point, armature part, just this resistance is very high. So resistance high means current is low. Okay, this current is negotiable or negligible. Okay, this current is, if suppose if current negligible, then I negligible means this current, shunt current less than 1. Okay, shunt current all time less than 1 ampere. Okay, so this current, if this current negligible, then this current negligible means this current suppose 0. If this current 0, then Ia is equal to I. Okay, clear? If this current negligible, this current 0, then VI plus this the 0. So I square RA plus WC. Okay? All are clear?
Yes, sir.
If this current negligible, not negligible,
Yes, sir.
but if this current negligible, then this. Okay? Now we are just value transfer this our formula. You know that our efficiency is equal to output by input. So output is equal to VI, and this input is equal to this input. So input is equal to now this value. Okay, this value. So input is equal to VI plus I square RA plus WC. Okay.
I
Okay.
understand.
All are clear?
Yes, sir.
Now just
Okay, sir.
step by step divide. Okay. Now just all parts are divided by this part divided by VI and this part divided by VI. These are two sections. Suppose VI by VI plus VI by this total. This total. This total means I square RA plus WC. Okay, so this is equal to 1. So 1 plus this. Okay. Or another solution. This is the simple solution. All part divided by VI. Suppose this is the VI, the upper part. This is the VI divided by VI, and this is the lower part. VI divided by VI plus I square RA by VI plus WC by. All are clear?
Sir,
Yes, sir.
All part divided by VI. All.
sir, but why?
This is the mathematical policy. Just calculation. If this VI divide, then calculation is easy. Okay, this is the math. So this is the VI and VI vanish. This is the 1. This is the 1. Okay.
Sir, but how? Why did I, divide in VI for all the equation?
Okay. This the very simple part. Just this the VI. So this VI, this I. Also this the our mathematical solution on is shorted. Then this the formula. All part divided by VI. All section. Okay. If this
Okay, what
all
kind
section
of
VI,
result did I get?
then our result is shorted. Okay. This is the condition. Suppose now this. This part is just erased. Okay. Now this the VI vanish. This I and this the square. So this one I vanish, and this not this the yeah. Okay. So now this result, so upper part 1 and lower part 1 plus I RA by V. Okay, plus WC by yeah. All are clear?
Yes, sir.
This is the short form of this part. Okay, this is the vi vanish. Now this is the 1. This vi vanish. Now this is the 1. This is the I. Lower part I. This is the I square. So 1I is vanished. So I RA by V. I RA by V. This is the WC by VI. So this is the WC by VI. Okay. Now, all are clear this part. Now,
Yes, sir.
you know that our efficiency is equal to, another repeat part, efficiency is equal to output by input. Suppose if this part both same, if this part both same, then our efficiency 100%. Okay, or if output suppose 100 and input 100, input 100 and output 100, so both same, or input 50, output 50, both same, then your efficiency must be 100%. Clear? Suppose into 100.
Yes.
Output, suppose output and input, if output and input same, so this is the vanish. So this is the 1. So 1 into 100. Now your
100.
efficiency 100%. Okay.
But
So
sir,
100%
how come the
efficiency.
output and
How?
sir,
If wait.
how come the out?
Wait.
Okay, sir.
If this part is same, if this part same, then efficiency 100%. You know that. This suppose this is the 1, this is the output, and this is the input 1. So this is the same, but this the point. This if this point, this value, if this value is equal to 0, if you prove this value is equal to 0, then 1 plus 0 is equal to 1. So 1 and 1. Now this is the 100%.
Yeah.
Okay, all are clear? If
Yes, sir.
Yes.
if this part is equal to 0, if this part is equal to 0, then
It's equal to 0.
then this
Then it should be 0 plus 1. Yeah. 1.
now this is the condition. If this part is equal to 0, then your efficiency, maximum efficiency means 100% efficiency. If this part is equal to 0.
100%.
Okay, clear? All are clear?
Okay, sir. Now clear.
Sir.
If this part is equal to 0, this both is equal to 0, then your efficiency 1 by 1, then 100%. Okay. Now we proved this is equal to 0. Okay.
Sir, but listen, sir. If I got in this loop, I'm talking about IRA divided by V. I'm talking about that that condition. If I got like 2, 3, whatever, and plus 1 and divide by 1. So if I got another result,
yes, another result. So then not 100% efficiency. 100% efficiency depend if this value is equal to 0. Now we not finish our equation. Okay, wait.
Okay.
Now we differentiate. You know that the differentiation, mathematical equation, differentiation, integration.
Integrations.
Differentiation already maybe finished. Differentiation mathematics.
Yes, sir.
Maybe your Anisur Rahman sir or ATM Mahbub Rahman sir. Okay.
Anisur Rahman sir.
Anisur Rahman sir already cleared your differentiation problem. Okay. Now we calculate the differentiation. Okay. Application of the differentiation in this generation part. Okay. Now we are differentiation only this part. Okay. This part is equal to 0. If this part is equal to 0, how the condition? This is the differentiation. This part. Okay. This differentiation d by di. This is the differentiation depend on current. Okay. D by di. This is the I RA by V plus WC by VI. So this part is equal to 0. So, okay, this part is equal to 0. Clear?
Yes, sir.
Now-
Clear. Sir, this
Now-
is
Okay, so this differentiation, you know that this is the differentiation equation. If this the
current.
current, your differentiation formula just use d by dx, d by dx x or 5x. Your result is equal to what is
Okay.
the result?
Only
So
5,
that
sir. Yes.
d by dx 5x is equal to result
5 times
5
it
ones.
should be 1.
only
5 times 1 will be
Only
5,
five.
sir.
Only 5.
Yes.
Yes,
So
sir.
this is the point.
Why
d
X
by
one?
dx, d by dx constant into x, this x and x. So your result is only constant value. In this fact, now this your constant value. Okay, this is the constant and this is the variable, this I and I. So this point differentiation value, this point differentiation value, what is this? RA by V.
Sideeda ku imaanaysaa. RAV, yeah. Sideeda ku imaanaysaa.
Yes,
Okay.
sir.
Yes,
Yes.
sir.
Because
Yes.
this is
Okay,
the
okay.
constant and this is the I. So I vanish, this is the constant value this. So this part is finished. Now this your another part. Your another formula just d by dx 1 by x. You know that.
X square, sir. X inverse.
anaga wax ma maqluun. Macalinka ma aamus.
ما غلط كم غلط. أنا جو فري. سنة كل ما كتدي ديو باريك سونا بايكس X square منها.
Haddii oo sidaan ay tahaa.
ديو باريك سونا. وهذه maybe X inverse منها.
Sidaan اختار keena. Niyo qadka macalinku wuu hadlo niyo. Qadka muso wallah.
macalinka ma hadlooyno muudow ku jiraa
Miya. Qadka teleefankeyga soo saarayno.
magaalka dhan waane xaafadeena daaqada u jira
Mana maqlo macalinka.
maya mas-uul
Ayhe macalinka ma mood galaniyo marka anaga ma qadka naga leeysan yahay.
Sorry.
Yes sir.
Now this the result. You know that this result. Okay. Okay, I will clear this. This the 1 by x means x to the power 1. Okay. 1 by x is equal to
Inverse
x to the
one.
power x. Sorry, x inverse 1. All are clear this. 1 by x is equal to x inverse
Yes.
1.
Yes sir, it's inverse, yes sir.
Okay, so d
Okay.
by dx x inverse 1. This formula, you know that x to the power n is equal to x to the power n is equal to at first this n value font size, then x to the power n minus 1. This is the main formula. Okay. This
Okay.
n is the font part, then x to the power n minus 1. This is the differentiation formula. Okay. So this is the minus 1, this is the n value. So minus 1 x to the power minus 1 minus 1.
Minus one,
This
okay.
minus 1 means n. So this is the n. X to the power. This is the n minus 1. Okay? This is your formula. N
Yes, sir.
x to the power. All differentiation d by dx x to the power n. This is the formula. This formula
Okay.
n x to the power n minus 1. Okay.
Funny.
So
Okay.
this n means our this n means minus 1. This n means minus 1. So this is the minus 1 x to the power, this n means minus 1. So minus 1 minus 1. Okay. So this is equal to minus x to the power minus 2. Okay. And this x to the power x inverse 2 means 1 by x square. This is the minus 1 by x square. So 1 by x is equal to minus 1 by x square. This is the differentiation calculation. Okay. Clear? All are clear?
Okay.
So d
Yes,
by
sir.
dx 1 by x is equal to minus 1 by x square. So
Got it.
this is the fact. This your constant. Constant is the fixed. 1 by I. So 1 by I means at first constant value. This is the 1 by I means minus. This is the minus. Okay. This plus and this minus. Plus minus.
Okay.
This is the minus. Plus minus minus. Okay. Now this is the constant value WC by V. And 1 by I. 1 by I means this. 1 by I means 1 by I square. This minus is this. So 1 by I square. 1 into WC is equal to WC. Okay. Into 1. So WC. This more. Okay. And this is equal to this 0. All are clear this? All are clear?
Yes, sir.
So this
Yes,
our
sir.
result RA by V minus WC by VI square. Okay. Now this differentiation finish. Now this part, this minus, so this part is this opposite side. RA by V is equal to WC by VI square. Okay. Now this, you know that this V and this V, these are multiplying, so this V and this V vanish. Okay, opposite side same, then this the vanish. Okay, this is your another mathematical formula. Okay, so this V vanish and this I is opposite the multiplying upper. Okay, this is the I square RA is equal to this, not this is the 1, so 1 into WC is equal to WC. Okay, so this your answer. All are clear this part?
Yes, sir.
Now this if this the I square RA means this is the variable. I square RA is equal to variable loss, and this is the constant loss. If this is the condition, if variable loss is equal to constant loss, then your result is equal to 0. Okay, this part, when this part is equal to 0, if this is equal to this is equal to this, then your result, this is the 0, this is the 0. Okay, and this the 0, then your max efficiency is maximum. All are clear? So
Yes,
our
sir.
maximum efficiency main condition, if your variable loss is equal to constant loss, our all losses is equal to our armature loss, armature copper loss, and all loss. If all loss and armature copper loss same, then our this part is 0 and this part is 0, then our maximum condition is 1 by 1, and 1 by 1 means our condition 100% means maximum.
100%.
So
Yes.
maximum efficiency main condition, armature loss and constant loss is equal to
Means, sir, variable loss and constant loss.
This variable loss means armature loss. Okay, armature copper
Yes,
loss.
also.
So armature
Yes.
copper loss or
Yes.
variable loss is equal to our another all losses called constant loss. So constant loss and variable loss
Yes.
same. If constant
Equal, sir.
equal, then our this part is zero. This part is zero, then our efficiency 1/1. 1/1 means 100% efficiency, then maximum efficiency. So maximum efficiency condition, this. Okay, this is the variable loss. Variable loss is equal to constant loss. Okay, all are clear? These are short form and these are detailed. Okay, book this is the short form and this is the detail. Okay, all are clear? Condition for maximum efficiency.
Yes.
Yes, sir.
Okay, thank you. Now here, solve on another problem. Okay. So this part is power stage already finished. Our efficiency, mechanical efficiency, overall efficiency is the vanished, and the condition for maximum efficiency is the vanished. We already finished. Okay. So this problem already finished. Now we just that suppose. Okay. Suppose now we solve this problem. Okay. Clear? Okay. This is the fact. A shunt generator has a full load current at 196 ampere at 220 volt. So our main part, this is the shunt generator. So at first to draw a shunt generator, all are draw this. Quick draw your notebook. Okay. Response please.
Sir, you can draw it.
Continue. Okay. হাসনাত কি তোমরা রেসপন্স করো না কেন? বাঙালিরা তো কেউ রেসপন্স করে না। থাকলে হবে একটু রেসপন্স তো করবা।
ওকে স্যার।
মাঝে মধ্যে রেসপন্স না করলে হবে। এই সাফি who is Safi? Roll number absent. Also
Haji.
Amir, your
Sir,
roll
I'm present.
present, but your roll number is missing.
Sir,
Please rename. And
my roll
also,
number is sir 7.
I know that your roll number 7, but this must be renamed.
Yeah, I know that, but sir,
চেঞ্জ করছিলাম একবার।
if I go back,
okay.
If I go back, sir, I don't have enough internet, sir.
Okay, no problem. But if you rename your Zoom platform.
Roland Batch.
Okay, Zoom platform. At first, rename your Zoom platform. Then automatically this system is run. Okay.
Okay, sir. Okay.
The main formula. Okay, no problem. Now this is the okay. ये चेंज कर दो, हंसना तो एक बार चेंज कर दो। साफी
আর আমি co-host নাই তো।
हंसना তুমি co-host নাই?
স্যার আমার ডিসকানেক্ট হয়ে গেছিল।
ও আচ্ছা, ঠিক করে দাও। সবারটা ঠিক করে দাও, যে আরো 3-4 জন আছে। Okay, now solve this problem. This is the
Sir,
shunt generator. Right?
it is class what?
Yes, class one.
Sir, show us
Already,
one example.
sorry.
Show us one example, then we will do
Okay,
it.
class work also I finish this work. Okay, no problem. This not your work. This is the combined work. Okay.
But it's how much, right?
No marks. This is the combined work. I solve this problem. Okay. Okay. This your shunt
Okay, sir.
generator. This your shunt generator.
No, macnaku wuxuu sheegaya saaxiibayaal wax ma maqlaaye.
Okay. This is the current flow. This IA, RA, and this is EG, and this current is the ISS, IL, the PL, RSS. Okay, and you know that IA is equal to ISS plus IL, and EG is equal to IRA.
IRA plus EL.
Okay, now your current, this is your current, IL is equal to 196 ampere. Okay, and this is equal to 2024. And stray loss. Stray loss, you know that stray loss means mechanical and mechanical loss and magnetic loss is the stray loss. Stray loss is equal to 720 watt. Okay, and shunt field coil resistance is the 55.
RSH, 55.
Okay, it has a efficiency, full load efficiency 88%. So
What do you mean
100%.
by FL, sir?
ETA is equal to 88%.
Not
Okay.
100.
Clear?
Sir?
Yes.
What's FL?
Yes, sir. What do you mean by, sir, FL?
Full load. Our
Yes.
load is
Okay.
full. Okay.
Yes, sir.
The
Got it.
load is full load. Okay, full load efficiency of 88%. Find the armature resistance. So RA is equal to hot, and also find the load current. If the efficiency 88%, then your load current, your previous load current this. Okay, clear?
Okay.
Also,
So
find the load current corresponding the maximum efficiency. This is the efficiency 88%, then this your load. But your maximum efficiency or means your efficiency 100%, then your load current, what is this? Okay, if your load current 88 efficiency 88%, then your load current this. But your next problem, also find the load current corresponding the maximum efficiency. This is the second part. Okay, at first finish the RA.
RA, yes.
Okay, at first finish the
Second
RA.
IL.
Okay, then load current,
IL.
then IL.
Yes.
IL if efficiency, efficiency, percent of efficiency 100%. Okay,
Yes, it's a maximum
efficiency
efficiency.
100%. Okay, this is your second part. Okay, now we finish this part. You know that this is the efficiency 88%. This problem, you know that you not understand the okay. You just this the ISA is equal to already no problem. ISA is equal to VSA by RSS. Okay, so VSH is equal to this and this voltage and this voltage same. So 220 by 55. So what's the value? 4. Okay, value 4. Using the calculator.
Yes, sir.
4.
Yes, sir.
Yes,
Yes, sir. It's sure.
4 ampere.
Value is 4, yes, sir.
So this is the 4 ampere. Then IA is equal to
It should be, sir, 4 plus 196 ampere.
so 200.
Yes, sir.
So IA no problem. IA finish. Then RA. So RA is equal to this this value, but must be needed this value. Easy. Generated voltage easy. Must be needed. Okay. So now our efficiency 88% efficiency. So efficiency 88% means you know that efficiency is equal to output
What by
by
input times 100.
input. Okay. So output input is equal to
Input is equal to, sir, 1 plus
input is equal input is equal to this output by efficiency. There is alternative. This is the upper part, this is the this. Okay. All are clear?
no, sir.
Suppose
We know that, sir.
5 is equal to I by 10. So I is equal to this 10 multiplying this part. Okay. Or this.
Sir, cross multiplication, sir. Cross multiplication.
This, yes.
Yes.
So this is the
5
cross
times 10 to be
multiplication.
50.
This is the
And
change.
sir, I
Yes.
said to you, you
Yes,
are
sir.
doing
50.
now.
So your output value 220, but this is not output value, this is the output only voltage. So output by input means this is the power, this is not voltage and current. Our efficiency all time, this is the use power. Okay, output power by input power. So output power, our output power is equal to PO. Output power is equal to 220 into 196. This is the output power. This is the V into I. Okay. All are clear? So output power multiplying. Sorry?
Sir, first we have to understand by each other. I said this is clear, but sir, we know that the value of output was, or the equation of output, it was, it was 1 times, in the loop, inside the in the loop, it was RA divided by V, right? Plus WC divided by VI. So how it should be, output divided by efficiency? How it should
Okay.
be? This is not the right equation of the input.
This equation, this problem, your value, this is the efficiency value. Okay. So efficiency value is equal to efficiency value, this is the 88% efficiency. Okay. So you know that efficiency is equal to output by input. Okay, this is the power stage. This map, we need the power stage.
Okay.
Yeah, I will have them.
We need the power stage. Sorry. Wait. the we need the power stage. You know this is the power stage. So this efficiency is equal to this is the output. This output and this is the input. Okay, you know that this is the easy IA. This part and this part is VI. Okay, and this loss is iron loss, iron and friction loss, and this is the copper loss. Okay, this part is copper loss. Okay, so this is your full power stage. So, if you find the efficiency, okay, if you find the efficiency, then this is the easy value. Okay, output by input. Then if you understand the input value, then input value minus still loss, then your this value, and this value is easy and easy IA. So easy IA already, easy IA is clear. Then easy is equal to this is the power. This power is equal to easy IA. And now easy is equal to P by IA. Okay, so this easy, calculate this easy, and this the, if you find the easy value, then RA is equal to here. Okay, so we need this formula. We need this formula. Okay.
Okay.
Okay, so now percentage, 88%. 88% means 0.88. If 100, if you into 100, then 88%. But now we calculate output value. Your output value, this, calculate this. Quick calculation this. 196 into 220. Okay, these are why I'm late. 120. Okay, so this is your output. Okay, 43 120 by this 88% means 0.88. Okay, so your result is, how's the result? Input result divide by 0.88. So these are 49
4907.
000. Okay. This
Sir.
what? This what?
Sir.
49,000.
Okay. So this is your input. Now you know that easy is equal to easy IA. Easy IA is equal to input minus histo loss. You know that your histo loss this
7207. Yeah.
this your histo loss 720. So easy IA is equal to this the input. Okay, input plus input minus loss. So input is equal to 49000 minus 720. So easy is equal to IA is equal to IA is equal to What's the value? Minus 720. So this value is 88, 48, 280. This one. Okay? All are clear? Now is equal to, is equal to 48, 280 by I is equal to 200. Okay. So divide by 200. How's the result? Divide by 200. So this is equal to not response. Why? How is the result? 241.4.
resultat kaligaa isku jiro.
Okay. Is equal. Okay. If is equal to this, then R is equal to, what is this? R is equal to, now you calculate
RA, you can
EG over, sir.
calculate- Yes, sir. You can calculate the RA because if you
Yes,
have the
sir. It's
value,
easy.
you have the
EG of
value of
IA.
IA, you can calculate it.
so this is the I
Right.
equal to,
wuxuu ka jira mataqaanaa stray loss-ku ka jiray. Laabtan ku jira. Macnaha adiga
wait.
xabuu ka keenay
Any
soo
problem?
maydo waxaan ku uri markii
Now
oo 4,900
at first finish this math. Okay. So is equal to is equal to IA RA plus VL. So IRA is equal to IA RA is equal to EZ minus VL.
Yeah.
Okay, so
Okay.
RA is equal to EZ minus VL by RA. Sorry, IA.
Yes, sir.
IA. So now finish. Is equal to 24, 241.4 minus VL is equal to 220. Okay, 220 by 200. Okay, so how's the result?
Okay, the result should be, sir, divided by maxaa u qaybisay marka 200
Minus 220 divide
0
by,
point yeah,
divide by 200.
sir, it should be 0.107.
Yes, 0.107.
Yes, sir.
Okay, this is your current.
No, it's your array, right? If I'm not
Sorry,
wrong.
RA.
Yes, sir. Okay.
RA. So RA is equal to 0.1071.
07. Yeah.
Okay.
You get the value. Our major resistor.
Okay. So armature resistance is finished. Now find the load current corresponding to the maximum efficiency. So you know that maximum efficiency.
Yes, your maximum.
Now erase this point. Okay. some erase. Now just calculation the maximum. If maximum efficiency, so maximum efficiency, you know that. If maximum efficiency, our formula I square RA is equal to WC. Okay.
Okay.
Hello.
Salebano. tirada oo waxaa sheegaysa soo maaha 8,400,280 xaguu ka keenay soo maaha oo waata
marka loo qaybinayo magaranaysaa power inputka loo qaybinayo efficiency-ga marka la isu qaybiyo waxay noqonaysaa 490 bay noqonaysaa laba siro markaa ku daray labadaas siro waxa ku keenaa lahaa
waa boqolka day Salemano waa times 100 ano the percent soo ma bash
100 buu ku soo qaraa
waa percent ani xataa kood waa la yaabana mugtahay intigina maartay 490 isoo markii waa ku waaya marka hadana bal 100 ka ku tijaabo marka saana isoo marka for 9k
So now this I square now I square is equal to WC by RA and I is equal to root over WC by RA. Okay, this I means this is the load current. Okay, now WC means constant value. You know that our constant, this circuit, our constant value, this is the still loss plus this part. Okay, this part our constant loss, this is the still loss, this is the 700
20 sir
20. Okay, this is the this part loss, and this part another loss, two losses, copper loss, two losses. One is the armature loss and another the shunt loss. So if you use the shunt loss ISH square RSH. Loss means power, so power means I square R. Okay, so this part loss, shunt loss. Now shunt current, you know that shunt current is equal to maybe 4. Okay, so 4 square into RSH means 55. Okay, so your result 16 into 55. How's the power?
880
880
watt.
watt. So this and this still loss plus still loss 720 0. Okay, and 0 this. Okay, clear? So this is your constant loss. Okay, so now root over constant loss this and RA is equal to already calculation is got RA is equal to this your RA. Okay, 0.107. So What's the value? Please quick calculation this.
Sir, 1,006.
Sorry?
For this, sir. If we square roots are 1,600, this will be 40 of our.
Total root over.
Okay, sir.
So total root over your result.
Sir, I got 122,128, sir.
Sorry.
Sir, in my side, I got 122,0128.
0.107. This value. At first, this value is 1,2,1,9,5,0,2,7. Okay. So the root over
I know I saw by 122,128. أنا أرت راديكال كده كل من
yes,
نقول
yes.
جرا مثال
Yes,
واي
good.
بنا.
This is your result. 122.
Yes, 122,127. 28.
Yes. Okay, this current. Okay, if your efficiency maximum, then this not 196 current. This current is this. Okay, so this is your answer. Okay.
Sir, repeat again that sentence. If the
This your question. Find the load current. This is the load current corresponding the maximum efficiency. If your efficiency maximum, then this your load current. Okay, this load current.
122,128.
Your
You mean?
previous load current this, but this not.
Yes, 196, sir.
Is the efficiency 88%? 88%, then your current this. If your efficiency 100%, this system your efficiency 100%, then current is changed. Now current this. Okay. Yeah. Okay. So now we check this. This is your resistance. Okay. And current this. Okay. Our answer is right.
Yes, sir, 122,134.
Yes, 3-4. Our answer. Oh, this not matter. Okay, point. So this the if your full part this no problem. Okay, 22. This is the 28 and this is not. Okay. Because this part is correct. This 0.107, okay, and this this part is
1,600.
okay. Wait, just directly we use this formula, then our result will be this. If you use direct root over first bracket 1,600 divided by
عليك محمود قولوا عادي.
meel kale ku qoran malay aniga kale wax ma ujeedo meel uu highlight gareeyay bas
Oh no, this result is correct. Okay, our result is correct. Clear? Our result is correct. These are wrong. Okay.
Yes.
If you this point is correct, both are correct, then this result is wrong. Okay. No problem.
83. 283.
This book many problem, many error. Okay.
Yes.
So this not better.
والله
So
بس نحكي بس
this your another problem. You solve this problem. Okay. Now
One more.
this no this your class work. Okay. If first person to submit, then grace mark 3, and second person submit, then marks grace marks 2, and third person this is the grace mark 1. But okay, this is the problem. We solve this problem. This dynamo means generator. Okay, this is
waqti anaga dhacaniyo wa sir
yes.
Now is it so much important to do this?
Yes.
Yeah.
This part only torque part no need. Copper loss and iron loss, iron and friction loss. Okay, these 3 losses you calculate these loss.
Here you can screen واحدة
ما تبي
Sir,
Okay.
the class is finished maybe, right?
No, today our both class,
easy شروط
also lab class. Okay, so lab is not possible the in this situation. Okay, this the directly attend the lab room, then lab all part is clear. Okay, but suppose you use the video, this is not clear your lab. So today our lab and theory both combinedly theory class. Okay, just to solve the mathematical problem. This problem, this part is on it. Okay, only you find the A value and B value. Quick calculation.
جو أفرت على شيء ما له معنى
يا
ما تنها على شيء ما له معنى
والله ابوك شكر يا ابني ما قرر
صاحب ولا shaqeeyo yani
محل لكن الدين سكر وين باش صحوه
tan kale way ka duwan tahay ma arkano
باش أنه لو إزرت بتوح واحد لو فكرة وين فودر صح لكن
ana
الدين
dhaayno kiin ugu dhigan
رتب عدو حيزي ولا عادي بس
imtixaana
ها
war laba xiisa aan lahayn jiro dhaam faanta ana isku wada loo dhahay marka oo isku wada qaadano dhamaadaan la
بسم الله
هاي نيو
الرحمن
ثانيتي
الرحيم
وكردويدي
rax jiro
ها دي ويكل دون سما
يا ديفرنس واضح هاي نيو
سيادي لو في مارتو حتى هارون ده صهومي قلنا سما صح
يا
هم
that's why oo dhaho ka dhiga dhan waa diidis
والله ما كنت عن تواني إنه في دي سما أنت لا فكر واي أرضي توش ولا حمونا
isku galaa ninkan
আকাশ আছো নাকি?
Hello. Okay, all are clear?
Clear?
Okay, thank you. So this date, next Tuesday, okay?
Next week,
Tomorrow.
next week. Yes,
Next
sir.
week.
On this day.
Next week.
Next week on this day.
Our rules is complete strict rules. This next Wednesday, if not submit assignment marks, stop. Okay?
Okay,
Must
sir.
be all are submit assignment submitted rules, all are complete this assignment, then screenshot or then one PDF, all are one PDF or screenshot, one-to-one screenshot this assignment submit my personal inbox messenger. Okay?
Okay, sir. Okay.
Messenger inbox. Okay?
Okay, sir.
So all are clear?
ما فهمتين معانكو سو أورو ما فهمتين شافعي مصطفى عبد الفتاح سليمان ما فهمتين ورا إدريسكم مقلني Idris
ما-
أنا
ما
في
يستع-
شيء
ما يستع- انت ضمن مثلا انت ضمن الشيء انت تستعمل قواعد انت تسمر وما يقرا
إيري أنا وش
اتكلم
إدريس
قواعد
أوكي لما إذا كلا كويس أنت مانو كلير
هذا وانا ما هذا ما
Now present.
أوكي هدوت مركز سؤال عمري أنا إسكو شيء أنا دي ماله إسكده هدوت إسكو شيء أوكي صار كلير it's clear
Okay, thank you.
ايوه
Now
ايوه
present. Okay. One. Yeah, now check. Messenger. Chat box. Okay. Chat box. At cost. Roll 21, 29, 21. Okay, 21. Then 29, 3. 3. Then 29, 7. 7. Then 30 dash roll 2. 30 dash. 30 dash roll 2.
في زمان ما قايل ما عرفت اليوم
Silent. 29 dash roll 16. 29 dash roll 16. Okay. Then 30 dash roll 14. 30 dash roll 14. Okay. Then 30 dash roll 8. 30 dash roll 8. Then 30 dash roll 3.
صح لا تسمى ما غلط عنه كان انا شيء
15. 30 dash roll 15. Who? Ibrahim.
Yes, Ibrahim.
30 dash roll 15. Today your first class. Right? 30 dash 15 roll is then today first class. Okay, then 30 dash roll 4.
Yes, rule 4. Me.
Okay, 29 dash roll 15. 29 dash roll 15.
كان يوم الشيء قبل اذا قيس انا ما غير
29 dash roll
سلام أبوك شيء أنا مقلع إسكو سكاي
29 dash roll 1. 29 dash roll 1. Then 30 dash roll 13. 30 dash roll 13. 30 dash roll 5. 5. 30 dash roll 5. 30 dash.
أبو ممي الشيغاني قبل وعاد مقلنا
نيو أضيق وحبوق القرنية يا سوق
So 29 roll 4 absent. Okay. And 30 guys roll
إسكي جيما
14.
مقام
30 guys roll 14 absent.
تادي باجرول 14
30 guys roll 9 absent.
No sir تادي باجرول 14 he is present هذا أركابه
30 guys roll 14 percent.
مصطفى معاني كل هذا
Mustafa.
تادي yeah تادي باجرول 14 is present sir I can see him
Okay.
Also,
Okay. 30
قد
guys roll 14 Mustafa present.
حسن عمل
Okay, I know. Mustafa present.
sir even تادي باجرول no 29 باجرول 4 I can see him sir they are online but maybe they have net problem as I can
That's not present in this chat box.
okay
At first to join, then must be important the chat box you present your roll number. Okay, so if mistake, then Okay. Then
Okay, sir.
all are finished. Roll 9, 30 was roll 9.
Batch roll 9. Bashir, one में Bashir.
30 was roll 9 may be absent. Okay. So thank you.
Amiru, assignment ko sheegay maxaa inuu qadka iga go'ay.
Hadhow taa idin sheega.
Okay, so today
group
our class finish, okay?
Okay, sir.
Okay.
Okay.
Okay,
Okay,
thank
sir.
you. Thank you very much.
Okay, I love it.
Okay, and today I will submit a whole video recording, okay? Your Facebook group, okay?
Okay, sir.